Alright guys, I want to hit the idea of dictionaries a little bit more. Something that I don't think I quite clearly enunciated well enough, although hopefully in the discussion on the books you'll get it, is that a dictionary can be used for a collection of data which is multiple objects, or it can be for a series of attributes for a single object. So difference would be something like
when is it better to use a dictionary instead of two lists of the same size?
two lists, meaning parallel lists, like we've been talking about in the past? Good question.
I guess it guarantees that they're both the same size.
Yeah. So the question is, why would you use dictionaries over lists? And I would say that maintaining the connection between the two is done automatically as a dictionary. With a list, you have the opportunity for failure. What do I mean by that? You have two lists, you want to delete a record from the middle of them, then how do you make sure that you're deleting the correct one? You know, you could delete it from list A, but how would you know that you were deleting the matching one in list B?
Throw off your indexes.
Right. So that could throw off your indices. Now, when you start talking about classes, you could have a list that was a list of classes, and then you would no longer need a parallel list in order to manage it. It would all be in one list. But I would just say that, yeah, let's Google that. Right, and we could have done the same thing in dictionaries. And I think in one version of the class that I've taught in the past semesters, I did have us do it with dictionaries. So a list keeps order, whereas a dictionary and a set doesn't. We haven't even talked about sets, I do not believe. We can. All right, yeah. Right, yeah, the big point of a set is that it is a unordered series of values, so you can't sort it, you can't guarantee its order when you print it out or when you process it, and when you add to it you only get one of each kind, whereas a list, you know, if you want to insert 10 tens in a row into it, that's great, but if you add 10 to the set and then you do that 9 more times, you're still going to only wind up with 1 10 in it. So it wouldn't be good for a series of test scores, for example, where you might be getting the same score over and over. So a list keeps order. When you care about order, you must use a list if your choices container is limited to these three, of course. A dictionary associates a key to a value. A set requires the items to be hashable. A list doesn't. We haven't talked about that. A set forbids duplicates. Lists do not. Checking for membership in a set or a dictionary is blazingly fast. So I guess my tendency, my urge is to use a dictionary any time that I know that I'm going to have a cluster of information and I want to be able to access it by a key. And yeah, there are other ways you could do that, especially if you have a list of objects. You could just start from the beginning and search for it, but like I said, it's easier to do it. You don't have to write your own code to do that. We need to get to objects pretty soon, and that'll make a little bit more sense. So the dictionary is specifically geared for matching up keys and data. So anytime you have a situation, do we really only have 3 people in here? Everybody else went out trick-or-treating.
Yeah.
Alrighty. Hey guys in the back of the room, I appreciate you being here. Alrighty, so
Make sure that recording's going.
yeah, I may not have started it. It is going, okay.
It's very important today.
So we haven't talked much about the idea of a hash. And by much I mean at all. Let's go to the first mention of it. So when you do something like this, if value is in your dictionary, it has to search it. The way it searches it is it turns this value, well, let's just kind of write a little bit of pseudocode for it. Adding to a dictionary. And the key is what gets hashed. So you have a key, and you're adding to it by names. Bob is your key. Bob gets hashed, which is a mathematical formula for turning that into a number that you kind of hope is unique. So say that gets turned into, you know, that number, whatever. And then you add, so then add that to the list. Then you have another key that you want to add, Carol. It gets hashed. It becomes a completely different number. That gets added to the list. If, when the key is hashed, if there's a collision, if it generates the same number through the algorithm, then it will be hashed a second time and a third time in order to get a unique key. And so those are used to do the lookups. When you're looking up based on key, it converts Bob into a hash, and then it searches the dictionary for that numeric value, which is a lot faster than searching for a string to see if the string will match. So as a list gets longer, the search time gets longer in direct proportion to the length of the list. For dictionaries, Python uses an algorithm, uses a hash table with a remarkable property. The in operator takes about the same amount of time no matter how many items there are in a dictionary. I won't explain how they are so magical, but you can read more about it on Wikipedia. So the ability to generate a hash and then look that thing up by a hash, as it says, is a magical thing. It gives you remarkably fast access into a data structure. And it's honestly been a long time since I wrote a hash function, since, you know, school, long time ago. So I can't explain how they work. But it's something that generates a numeric key based on the data that you're passing in, and it allows it to be retrieved much more quickly. So write a program that reads the words in words.txt and stores them as keys in a dictionary. We have done that. A dictionary is a set of counters. We have done that. We could have done our bar chart based on this idea. And I'd like to go ahead and do that. Here's our question. If we were going to do this, you know, one way or the other. So our goal here is to write code that will count the number of each letter in a string. So, you know, Bobby Bobertson has how many B's in it? It's got 1, 2, 3, 4, 5, 6, you know. It's got 6 B's. How many E's does it have? It's got 1 E, you know, and so on. That's what we wanted to be able to do. So it's going to read this string in, go line, character by character, figuring out the frequency count, how many B's are in it. That should sound pretty familiar. We have done something very similar to that, I believe. No, our bar chart didn't actually do that. I'm getting my semesters mixed up. So our choices, we could create 26 elements. You know, number of A's equals 3. If you find an A, you add it to that. You do that with a giant if, else if, else if, else if structure, which would be very inelegant. What if you decide to add Russian letters to it? You know, all of a sudden you have to add, you know, 40 more else ifs in order to get it towards. You could create a list with 26 elements. The list could be 2 parallel lists, one the list of characters and the other being the corresponding, you know, values, the counts. Or you could create a dictionary with characters as the keys and counters as the corresponding values. The first time you see that character, you add it to the dictionary. After that, you would increment it. Each of these options will give you the same results in the end, assuming you just print it out and you're done. But each of them implements the computation in a different way. So let's write a little bit of code that will do that. File new. I feel like being wacky. We haven't been doing our main method declarations like this. I feel like doing it. So we're going to need that code at the bottom of it. Is it if underscore name equals quote underscore main? Is that the syntax? Call main. I need to see if that works. Make sure I got it right. So I'm going to do a save as. Save it in my scripting directory. October 31. Right now, all main's going to do is print hi, just to make sure that my little 2 lines of code down here work. I really wish I'd been reinforcing that the entire semester. Okay, that works. So what do we need to do? We need to ask them for a string to count the letters. Really, it'd be cool to open the file, read in all the letters out of it, you know, whatever. But, so let's ask them. Our data is equal to input. Type in a sentence. And then our dictionary is equal to, no, that's a bad word to use. Our letter dictionary, letter underscore dict, is equal to process our data. We're going to have to write a function called process for that to work. And then let's do a display results with our letter dictionary. You know what? I don't like letter dict. How about making that results equals process data, and then we could display results passing in that dictionary like that. So we need 2 functions there. One's called process, which is going to take this string and build a dictionary based on it, and then return that dictionary. The other one, which is going to display all the data in that dictionary. Suddenly I become concerned about whether the keys are going to be sorted or not. We may have to fix that.
Dictionaries automatically put its own order.
Yeah, let's. In other programming languages, you have the choice of using a dictionary that maintains sorted order and not. So if they do it automatically in Python, that's cool. All right, so we need to write a function for process and for display results. Let's just write little dummy functions first. Process takes a string. Why not just call it data? We're just going to print that data. That's it. That's all it's going to do for now. That's enough. Oh, and while we're at it, my name, program, calculates frequency of each letter in input. Alright, so this is called creating stubs. Stubs are just little functions that don't do anything that you're going to come back and fill in later. So display results is our other function, right? Okay. And it's going to take in a variable called results, and then later it's going to print them out. But for now, let's just print results. Now this isn't returning anything at all. So when we print our results, all it's going to do is print the word none. So I am going to stick a return word in here, which we're going to fix, right? And I did not mean to put this in quotes because I just want to print the variable out. All right, so I changed that to return, or I added that line, no results. Took out the quotes on that one, and I'm ready to run it. All right, type in a sentence. Hello there. Hello there. No results. Okay, great. It's all hanging together. It's just not doing anything yet. So what process is going to need to do is to declare an empty dictionary and then use a loop, pulling out character by character, kind of like when we turned that file into a list. Using the split command. Instead, we're just going to read character by character, but we need an empty dictionary first. So results is equal to dict, like that. Now we have an empty dictionary. We're not going to print our data out. Or I guess we could, you know, print processing, comma, data like that. Just to let us know what we're doing. Let's modify our return statement while we're thinking about it, otherwise I'm prone to forget, to actually return our dictionary. And let's put a comment about what this does. Takes a string, processes it character by character, returning a dictionary with frequency of letters. Alright, it still doesn't do anything yet. When we run it, we're not going to see anything useful. Yeah, okay. But we'll get there. We'll get there. To do this, we need a loop. We need a loop that starts with the first character and goes to the end. I don't much see a way of... I don't think I can use a for x in list structure in order to do this. You know, for x in L or whatever we were calling our string. I think that's for lists. So we're going to have an index number. So we're going to have to use the for x in range syntax. Or you could write a while loop. For, except I like I for index. For I in range, the length of our data string. Let's just print I out. Kind of showing you how I do things when I do my programming, which is make little changes and then run it until that becomes incredibly tedious. So I run it, type in a sentence. Hello there. And it printed out I. Okay, that wasn't very impressive. Let's get the character at that point. CH is equal to data at position I. I'm going to take that print I out. That didn't tell us a darn thing. Guess I could have added another comment. Loop through string. Now when we're going to add to a dictionary, what do we want to do? We want to make sure that it's not already in the dictionary. If it is, we're just replacing a value and it doesn't do us any good. So how do you check to see if something is in a list or a dictionary? What's the syntax for that?
If in dictionary.
Right. If the character is in our results, we're going to do something different than if it's not in our results. If character is in results, then let's get the count out of the dictionary. Count is equal to results for that character. And then results, kind of doing this a long way. We're going to add one to our counter. And then results is equal to, that's actually enough. Because if this isn't true, we're just going to set the count equal to 1, right? If it's the first time we find it, our letter count is 1. If it's the second or third or fourth time we find it or whatever, it's going to be equal to the previous count we've ever found, plus 1. All right, now let's put it in the dictionary. Results for that specific character is equal to our new count. That ought to do it. We could add comments, but I mean our syntax is pretty clear there, I hope. Type in a sentence. Hello there. Alrighty. And these are the results. It found 1 H, it found 3 E's, it found 1 L, 2 O's. Couple of changes I would like to make to it. Can y'all think of any changes? if this is only to process letters and not numbers or periods or things like that, what could we do to make it more awesome? What did we do when we were reading in our file, our Edgar Allan Poe quote or whatever we were trying to read in? We converted everything to uppercase. I think that'd be useful here. I don't see why we should treat uppercase and lowercase h's as separate letters. And another thing is I would like to make sure that it really is a letter. I guess we could do numbers too. Numbers are cool. But let's not do periods and commas and things like that. So here's what I want to do is after we get our character, I want to turn it uppercase. Then I want to check it, or even before I do that, I want to make sure it's a character at all. We can do that in either order, but why don't we do the first check? Or that wasn't clear. Why don't we check to see if it's a character at all? How do we check to see if a character is a letter or a number? We had a function that we could call to see if something was a letter or a number. Remember that? Things like isDigit, isAlnum. That should do it. So if this is going to involve a lot of tabbing if we do it this way. I guess that's okay, but here's my urge, but it would require using a continue statement, which we really haven't done much. So I'm just going to stick to our tried and true syntax. If ch dot, is it isAlnum or just Alnum? IsAlnum parentheses, colon, then do the rest of this stuff. So take all of that stuff, all of those lines, and tab them over by one. I'm going to add a few comments just to keep track for myself of where I am. I'm going to add the comment endIf here and the comment end4 here. Since Python doesn't use curly braces to keep track of things, I'm cheating and using comments. Now once we know it's a letter, let's go ahead and convert it to uppercase. Where would be the right place to put that? And yeah, we could have put it even as soon as we pulled it out there, but to me it doesn't make sense to try to turn a 1 or a period or a question mark uppercase. So where's a good place to convert our letter to an uppercase in this code? Right. Maybe, yeah, after this one, before that one.
Oh, you put ch.isUpper. Wait, no.
Yeah, I could check to see if it was uppercase, but let's just make it uppercase. ch is equal to ch dot upper. How about that?
Yeah, okay.
Type in a sentence. Hello there. All right, I'm liking that better. We don't care about spaces. We don't care about question marks, exclamation marks. All righty. I hope that kind of made sense. This was an example of using a dictionary to hold an aggregate of data for different objects. And what do I mean by that? We were keeping, track of A's and B's and C's and D's and E's, and those were all different pieces of data. Whereas on Thursday, I demonstrated making a little email type thing where you put a single email message in and you stored the header of it as one entry in the dictionary, and you stored, the subject, all that kind of stuff. All right, everybody get this working. No, we haven't finished it really. We haven't done anything except print the results like that. I'm kind of okay with that, but I'd like to print them out in a better format than that. User doesn't want to see this kind of output. All right? They don't want to see that. So if we go back to here, are we going to see Yeah, they did the same thing we did. They're not showing us the code, but that's okay. We wrote our own code. It's a histogram, statistical set for a set of counters. So now we want to print it out. We want to print out every element in the dictionary. And I'm not quite seeing an example of that. Here we go. For every key in the counts, print the key followed by the entry of the dictionary for that key. Let's put that on our results function. We could almost steal that line right there. We could steal those two lines, but I'll type them in. I like typing. Okay, so here's my display results. For every key in our results dictionary, print that key value followed by the dictionary entry for that key. Good enough. That's probably all it will take. Now is the time for all good programmers to learn Python. Alright, it is not sorted really, which is kind of odd because I think if we just printed the results it would look sorted. Is that not the case? To test that, I'm going to print the results again and give it the same data. It's probably displaying them in hash order rather than key order.
I think it's typing the order that it receives
Oh, is that true? A, B, C, D, Z, Y, X, W. Yeah, that's exactly what it did. A, B, C, D, Z, Y, X, W. Okay, my mistake. So can we sort the keys in a dictionary? Sort keys, dictionary, Python. How to sort a dictionary by keys. Python 2.4 or greater. You can use the sorted command. That sounds good. That's a built-in function. I like that. Okay. For every key in the sorted results, print out. Joe likes programming. And there they are. Alright, that's really spiffy. Now in a previous semester I had the students draw a bar chart based on these counts. Y'all have already done a bar chart. I'm not sure how much more you'll learn by implementing another one with this. But it's cool. And you're going, no, I don't want to do that again.
Start from scratch.
Alrighty. I'll contemplate that. So that's dictionaries. What are dictionaries? A structure that holds pairs of data, keys and values. And you look them up based on their key, and you get the value out of it. And you got to make sure that the item actually exists in the dictionary. If it doesn't, it will generate an exception when you try to pull it out by its key. I guess I'm just going to go to main and add some code that demonstrates that. Or heck, let's make one more function called dict stuff. And let's put a call to dict stuff. Kind of wish I chose a different name. Dict stuff right there inside of main. Alright, so we're going to create an empty dictionary. Example is equal to dict. Let's add a few things to it. Dict for Bob, comma 34, 32, that's how old Bob is. Dict for Sue, is 29. That's how old she is. Good enough. Now let's find out Bob's age. Age is equal to the dictionary entry. Okay, that was not supposed to be dicked over and over and over. That was my mistake. What should I put there? Example, because that's the name of my dictionary. Why don't I make a better word than examples? Ages. How about that? That's clear. And then we just replace these two words, dicked, with ages. So let's get the age of Bob. X is equal to the age of Bob. Let's print that out. Ages. Let's print out Bob. And then his age. Now let's get Becky's age. X is equal to ages Becky. Not going to work, right? Let's print it out. Print. Why did I not put quotes around Bob? There we go. We needed quotes on Bob on that one. And let's do the same for Becky. Becky, comma, X. This is the line that's going to crash. And it did blow up. Ooh, we even got an error on that one. Yeah, my syntax there was totally garbled. It's ages, and I'm so sorry about that. Ages, square brace Bob equals 32. That's how you add items to the dictionary. I don't know what was wrong with me. And then ages, square braces Sue, end brace is equal to 29. Just like a list, except a list wants you to have numbers there, right? But a dictionary lets you put in any value there. All right, so it didn't find Becky. How would we clarify that? How would we make sure? Yeah, we have to search the dictionary, and we have to use the in function to check to make sure that the key exists. I think that's likely it, but something was nagging me about it.
Too easy.
It's when you want to check to see the value out that it gets a little bit different. And I thought we had a better syntax for that. Okay, so yeah, let's do that. If Becky in ages, colon, we can get her name out. We can get her value out. We should do the same thing for Bob, in case Bob is there. So I'm going to stick another if statement in there just for consistency. If, quote, Bob in ages, colon, get the value, and then print it out. So Bob was 32 and it skipped it for Becky because she wasn't there. Very well. So dictionary lets us store pairs of values, a key, and a value. So dictionary key equals value. That's how you assign the dictionary or add something to a dictionary. If you want to get it out, you do value is equal to dictionary subscript key. This will cause an error if key is not in the dictionary. So if key in dictionary value is equal to D key, like that. Kind of consider those the most important concepts out of the dictionary. Oh, and creating an empty dictionary. I didn't do that. Let's go up here and do that way up at the top. I mean, if you're typing these notes. If you're not, I'm going to upload them. But anyways, D is equal to dict, create empty dictionary. And then D key is equal to value, add this key value pair to the dictionary. Then get the value for the key. Get the value that matches the key. Okay, so another example, like the email example. Let's make a person object. Person is equal to an empty dictionary. The person's name is equal to Joe Johnson. The person's age is equal to 32. The person's address equals 123 South Main. Like that. So again, now we're not dealing with thematically a grouping of different objects. Instead, we are describing attributes of the same object. This is kind of like a poor man's object-oriented programming. We will learn a better way of doing this. But for now, let's make a method, a function, which could print that information out. Display person, display underscore person. And we're going to pass that person into it. So now we're going to have to add a method called display person. And your question maybe as I type this, wouldn't you have to put display person up above this? No. Just roll with this for now. We could use that same thing, just rip through it for key in the object, print that key, followed by the word is, followed by the dictionary value for that key. Like that. It's probably enough. Yeah. So his name is Joe Johnson, his age is 32, his address is 123 South Main. So who could tell me, who could hazard a guess as to why, when every other time I've had to declare the function before I called it, this time I got away with doing it after I called it?
Doesn't it define all the functions before it starts running any of them?
Exactly, especially since our code is kind of running from the top up in a way. It runs all the way down here, building the entire internal map of functions before it starts doing anything. So, this function has been defined before it's been called by virtue of the fact that we processed the entire file before running anything. And when I say we processed it, Python did. Python went down to the very bottom before it could run anything. And so every function was already loaded. All the DEFs, were loaded and ready to go. So it didn't matter in which order we called them. All right, I've added a lot of code. Anybody need typing time, need a printout?
Oh yeah, could you go back up to the process function?
Sure. Yeah, that's the most important one, really. The process function. Okay, I really don't talk about sets too much, and I really don't talk about tuples too much. And those are like 2 entire chapters of the online text. We could knock those out in a day. What I want to get back to, or get to, is graphical user interfaces and classes. I may just mention sets and tuples and then maybe loop back to them. So I don't think we're going to do a full-blown chapter on sets and tuples at this point. So for a set, may as well hit let me make absolutely sure we've covered everything in here that they want us to see. Dictionaries and files, I think we did that. We did an example of that, reading the entire thing and creating a word count of them. Yeah. Looping in dictionaries, we know how to do that for key in counts, and if you want the keys to be sorted, you use for key in sorted counts. I need to add that to my so to iterate, traverse a dictionary, you could use for key in dictionary, and then value is equal to dictionary subscript key, or you could use for key in sorted dictionary, value is equal to key. Alrighty. I don't know what that's doing there. This is using a method called translate. I'm not going to talk about that. How about that? Debugging tips. If you're working on something, reduce the size of the data set. What does that mean? If I tell you to write a program where you're keeping track of, the rainfall for every day of the year, typing in 365 values would be a real drag. Just do it for 10, and then later on expand it to 365. Or if you're doing months, just make your program handle 4 months or something like that. If you're typing it in by hand, so that each time you run it, you don't have to type in a million things. Write self-checks. Sometimes you can write code that checks for errors automatically. If you're computing the average of a list of numbers, you can check that the result is not greater than the largest. So if you've already calculated the average, you could say if average is greater than max of your list, then it's a problem. You could print an error there. Pretty print the output. Formatting your debugging output can make it easier to spot the error. When I ran this code here, and we saw that that output just in raw data form, this is a sentence like that. That's hard to kind of debug. Visually, it's just difficult to process. Pretty printing is making sure that it's easy to process. Just like that. Same for like bar graphs, you know. You don't have to have bar graphs to understand data, but it makes it much easier to understand trends if you do have your bar graph, if you're doing statistical analysis or whatever kind of graph you need. If you want to read about hashes, go for it. What is a histogram? It's a set of counters. An item is a key value pair in the dictionary. So a dictionary is composed of a set of items. Set's the wrong word. And then each item consists of a key and a value. To look up is to check the dictionary based on its key, and it returns the corresponding value. We know what a nested loop is. It's when you have a loop inside a loop. All right, I'm not seeing anything really cool there, so let's bail out of that. Let's hit the idea of tuples. It looks like they skip sets entirely, so okay, that's cool. What is a tuple? It's a sequence of values, much like a list. The values in a tuple can be of any type. They are indexed by integers. The important difference is that they are immutable. In a list, you can change the first item of the list, right, or the third item of the list, or whatever. Once you build a tuple, you can't start changing it. So here's an example of building a tuple. That's interesting. I never even saw that syntax of leaving out the parentheses. Apparently it works. Looks like Python too. Anyways, so here I'm going to create a tuple that consists of A, B, C, D, E. Now, tuple is a statistical term for a set of values. Like you can have a double or a triple, or a quadruple. A tuple, you just don't know how many items, how many values you're associating to each other. So here they create a tuple out of the word lupins using the tuple keyword, and it splits apart that string into individual characters and makes a tuple out of it. All right, I'm not really liking their example here. So we're going to roll our own. I think I'm going to make a new file though. That one's kind of cluttered. Save as October 31B. So T1 for tuple 1 is equal to parentheses Bob, who's 32 and goes to OSU. T2 is equal to Joe, who's 18 and goes to OCU. And of course we have to have a Rose State student, so Sue, who's 21, goes to Rose. So let's print them out. Print T1, print T2, print T3. Let's print some values out of them. Print T1 index 0, print T1 at index 1, print T1 at index 2. So when you were asking about using a list as opposed to a dictionary, if you made a list out of tuples, you could do all the same kind of stuff as you do with a dictionary without having to worry about parallel lists. And we'll demonstrate that real quickly. Let's make a list. So I'm going to define an empty list like that, and then I'm going to add this stuff to it. L.append T1, L.append T2, L.append T3. All right, when we run this, it's going to seem kind of cryptic because we didn't put any descriptive stuff. So why don't we go ahead and put some quotes in our print statements just so we know what we're printing. like T1 equals, comma T1, that kind of stuff. T2 equals, quote, comma T2. T3 equals, quote, comma T3. Let's do the same for T1, T2, and T3. So T1 0 equals, quote, comma. It's kind of tedious. Now I'm getting tempted to cut and paste. T1 subscript 1 equals, quote, comma. T1 subscript 2 is equal to, quote, comma. So tuple is like a little bitty list. Heck, it doesn't have to be little bitty. You could create a tuple that had 100 items in it if you were capable of, you know, if you had the patience of typing in 100 things separated by commas. But let's run this, see what we get. All right, so I have 3 tuples now. T1 is equal to Bob, who's 32, going to OSU. T2, Joe is 18. T3, Sue. And so inside of T1, element 0 is Bob. Element 1 is 32. Element 2 is OCU. Now, honestly, we could have done these with lists just as easy. All we would have had to do is change the parentheses to square braces, and we would have 3 little lists. And this would be behaving exactly the same way. The difference is that a list can be changed. We could do T1 0 is equal to George if it was a list, and it would change it. So it was George 32 OSU. But by defining it as a tuple, you're guaranteeing that these values do not change. Is that important? Yeah, I suppose in some applications it could be. As we go through the chapter, we'll see if they give any good examples of that. But we created a list of these guys. Let's process that list. We're going to use a for value in list syntax. But firstly, let's just print our header. Print %10s for the name, %10d for the age, no, these are all going to be strings, sorry. %10s for the age, doesn't need to be that wide, does it? And then %10s for the school, end quote, %sign, and let's print out the strings, name, comma, age, comma, school, like that. And I forgot my last parentheses there. Got something to ask you. Does this syntax look familiar? We're passing in a tuple into the print function right there. All right, now we're going to write a for loop. For value in our list, print, okay, I'll type it in by hand. The name is 10%10s. The age needs to be a number, so %10d. And the school is another string, so %10s. Followed by a %sign. And I'm just breaking it up on 2 lines for my usual reason, to get it to show up on screen. You don't need to do that. On the next line, I'm going to put in that value, subscript 0, square braces 0. Value, subscript 1. Value, subscript 2. And then my 2 closing braces. And I have a semicolon here. And do we need semicolons in this language? We do not. I need to delete that semicolon. Probably isn't an error, but we don't need it. All right, so when I run it, I'll bring the code back up. Here's what we see. We have a cute little table here. And if you can print it out as a table, you could store it in a file, you know. send that data to functions to do something with. You could rip through it and calculate the average age of your students in your schools. You could rip through it and find out how many students are going to each school. That'd actually be a cool combo assignment. Don't think I'm going to do it, but it'd be more interesting than the itty bitty assignments that we have. Create a data file that consists of hundreds of students and their ages and their schools, and ask you to calculate the average age, and then ask you to create a frequency count of each school. That's a neat assignment. Who knows if I'll inflict that on you or not. I'm not planning on it, but I like it. Okay, so there's our code. You see what this is doing? We have a list of tuples, and we're just ripping through the list, printing out the values like this. And this is just a pretty print, the syntax. You know, you don't need %10s or whatever to format your output, but it makes it look prettier.
Can't we just put in the word value? Once?
Oh, well, if we, yeah, let's comment this out and just print out the value and see what we get. And yeah, you'll get some output.
No,
Just not going to,
after the percent sign instead of each value in the tuple.
is that going to work? You may know something I don't. That'd be cool if that works. Oh, you see what it's doing? It's treating that value as it's converting it to a string and just sticking it into the first placeholder.
It worked for me.
All right, I want to see how it worked for you. Just a second. All right, my first mistake. I don't need to be printing the value out and then the formatted version. Cool. How'd you know that?
I just tried it.
All right, that's slick. I did not know that worked. All right, my brain just restructured itself. That means I want to play with that idea. I'm going to create a dummy list of values, right? Colors equals, silver, red, orange, blue. And then I want to print that out somehow. Print %20s, 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 end quote, %sign, the colors. It's going to fill in all four of those values automatically. That is too slick.
It doesn't like that.
Didn't like that one. But you can do it with a tuple. Let's change it to a tuple. Put parentheses here. Well, what do you know? My format looks different because my font's larger. I should just change these to 10s. Isn't that awesome? I know the rest of you are going, why is he so excited about that? That just blows my mind. I never saw that before. It means that it will turn a tuple that, yeah, you're right, because when I said that's a tuple, right? When I pointed that out and I said that's a tuple. Yeah, exactly. We could store that in a variable, call it header. Header is equal to that stuff. And then I could print out the header. Pretty print it like that. Neat. I learned something new. I'm happy. All right. So those are tuples. Tuple's a list that's immutable. Can I prove that? Yeah. Since I have this these colors here, I'm going to change the first color to gold. And then the answer is no, I'm not. If I do color 0 is equal to gold, it's going to give me an error. Boom. Tuple object does not support item. Okay. So get rid of that. Tuples are like lists, but they are immutable, immutable, meaning you can't change them. Oh, it's almost time to go, isn't it? All right. What if you had to make a new one? You could. It would look something like this. Colors is equal to gold, comma, colors subscript 1, comma, colors subscript 2, comma, colors subscript 3. There. Now we have created a new tuple where the first value has been changed. I've never seen that syntax, but you could do that. Don't know why I'm staring at it. I guess I want to print it out again. So I'm going to take my print statement here, copy it, paste it underneath it just so I can see that that changed. Then we'll call ourselves done. Yeah, changed it to gold. Changing this in a list would have been super easy. We would have just done that rather than do that. I'm going to cut this example and move it closer to the place where we achieved it, and then I'm going to be done. Anybody need a... I don't even see a printer here. I keep offering printouts. Never mind. I'll scroll up and down if you need it, but let me create the drop box for this first. Alright guys, refresh your Dropbox. And we are done. Any questions? Everybody get the code running. Alrighty.